So we will switch to Java. Can you hear me? Yes. And I will introduce Helidon 4 here, which is going to be a little Helidon Meetup. And this is me. You can find me everywhere on Twitter, and all the other social networks out there. So you have the same handle. I work in the Helidon team together with David here, so we are both Helidoners responsible for the stuff. And what is the Helidon? Well, Helidon is a microservice framework. It's for like microservice. Obviously, to explain it fast, Spring Boot is our main competitor. So we are something like Spring Boot, just faster, better, leaner, nicer. Just pick one. We are Kubernetes friendly, obviously, because that's where microservices are usually running. We are 100% open source, even though we are backed by Prague. You can find all our sources in GitHub, and you can make a contribution. It's very easy. And you get some commercial support if you buy the project for Helidon 2. With Helidon, you can get two flavors. It depends if you like to make things yourself and care about performance and play with things a little more. There is no magic, no annotations there. I think it's a build a pattern and do it with lambdas and you have to do everything yourself, but you also what you do is what you get. There is no magic anyway. Then we have Helidon MP, which is quite the opposite. That's for most business-oriented developers. So you get all the annotations and the magic happening for you, so you can just concentrate on your business code. We are implementing microprofile specification. You get the CPI and JavaUser. So the resources you have been used to with Jersey and Helidon. All the Jakarta APIs, Helidon 4 is since Helidon 3 we are completely Jakarta 5. So no Java scheme space anymore. And there is Helidon under the hood running the things. You just have to pay some performance price for it because of the abstraction. So this is the difference between those two units. The Helidon SE here, it's very simplistic. You have this builder pattern, you register routing. This is the technical for the web server. You get nice word out of it, and you call it Scala. It's a simple lambda, and they give you the thing which is right, what you get. With Helidon it's very standard JavaUser resource, so you just use a bunch of annotations and you get the same thing without really firing things together yourself. And there is a C under the hood again, so it's just all the magic nicely wrapped for you in Helidon LP, run by the powerful Helidon C core. We have three implicit packaging options when you create a typical Helidon project. By default, we are doing the typical Java. This is very practical for the microservices because it's a deployment. You get separated layers from the libraries and for the business code. So when you change your business code, you don't have to push all your dependencies up to some remote repository. Instead, you push only the part of the changes. You change the business code. Just use the whole dependencies you are using. Then you can use the JVM image. With JVM image, because we are fully JPMS compatible, all our modules are really Java modules. So if you use JVM, then it is a efficient thing which uses all the unnecessary parts of JPK, right? So you get some site selection thanks to it. You create a Docker container, which doesn't need any additional JVM in it. You just run on Swat applicable the word, so it's just empty Docker container with your JVM application. And you get the site selection thanks to the GTMS modules. This is not data wrapper. I've actually created our hello world and created the JVM component. and it was 74% size reduction when I counted whole JTK, whole runtime, and our application. JTK didn't offer different. You also can make a native image. With Helidon, we are trying really hard to make Helidon compatible with native image. With that, you can get even better size reduction. Again, you need then only the empty Docker container and your binary application activated in the solution. Then you are to go. So those are the three packaging options we have. I have some more numbers here, so that's important. Also with JVM image, there is this house called class metadata sharing. Yeah, that's it, right? CDS, yeah, exactly. So you are almost on practice. And what we are doing in typical web server, we are carrying out concurrency. That's like the hardest thing that needs to be done. If you are using your web server, it's usually a heavily concurrent environment, and you need to handle a lot of parallel calls from all the clients, and you have to respond with really low latency to all the requests, and while calling some other services somewhere else, like the databases like MySQL or some other HTTP clients and so on, some messaging, usually stuff is happening, right? And there is some limited memory, of course. There's always some limit. We need to spend some CPU, and less we spend, better is better. So why would you want to optimize? Because it's the counting, right? And your manager actually directly see at the end of the month how good programmer you are. Because if you are not programming, not doing your work good enough, it's going to be expensive. There's like more CPU cycles, you have to start more code stuff like Kubernetes, and it will be more expensive. So we are trying to give our users a really good head start by optimizing as best as we can. Why is this heavy concurrent environment expensive? Well, in Java, we are using we are actually wrapping the kernel threads right now. We have been until recently, right? And it's been one-to-one. So each kernel thread, each thread packet in Java is actually creating a kernel thread, and creating a kernel thread is sort of memory, it's like 4 megabytes. It takes some time to start it. It's always like a operating system scheduler. So the starting thread is expensive, and there's also context tricky, which is when this is tricky when you need to you don't have anything to do in your thread, or the thread is getting blocked by some other operation. The operating system scheduler unloads the thread from the CPU and loads another one. That's scheduling the operating system does. Other problem is that there is a lot of those megabytes of memory right involved. So there is a lot happening just switching those kernel threads in the CPU. Also, the more of the threads you have started, the longer this stays, the more expensive it is. It's context switching. So usually in the web servers, we are trying to avoid the context switching. We are trying to avoid starting new threads. However, we're doing that in the last decades. We are using thread pools, so we've been reusing already started threads. That makes everything way better, it's way faster. And we are also trying to avoid the blocking of the thread. Rather, we've been trying to keep one thread really busy and schedule the work for it ourselves, because we can do it way cheaper than the operating system scheduling. And how have we been doing that? With reactive programming. right? Is there anyone here who's using proactive programming? No? Yes? Yes. So you know it sucks, right? It's terrible. It has very steep learning curve. It takes years to actually understand it. It's a nightmare to troubleshoot it. The stack traces which are very nice in Java, otherwise are useless. All the comparison issues are there's no order of things because everything is really complex and you are jumping from there to here. When you are debugging, you are again jumping from there to here. So it's really hard to maintain it, it's really hard to do it right. Even if you are looking at your own code in a few weeks, you will have trouble to understand what is happening. And there is a callback hell, of course. And it's also infectious. Once you use it, you have to use it everywhere. So this reactive APIs are growing through your code base, and if you want to keep to be performant, you have to use it. So all your code needs to be reactive, all your code needs to use those terminal callback, and you end up with this octopus like that everywhere in your code base. But we have a better solution now. With the JET 444, it was the two tests delivered. It was also a structured concurrency, but it stays preview yet, and some debugging tool set there. But in Java 21, we got actual virtual threads. Virtual threads are very same trick how to avoid the context switching like in reactive programming. It's doing exactly the same thing. It just hides it behind the scenes, so it's not your problem anymore. It's scheduling the work for you. So each time you are blocking, it's instead of keeping operating system scheduler to reschedule the it's happening behind the scenes, still in Java. It changes. It works only with part of the stack, so it is very cheaper. And now you can have millions of threads very cheaply. You can start them and you can dispose of them, and they are not actually disposed because those real physical threads behind the scenes are being reused like it would be with reactive programming, just way cheaper. If you look at it from your perspective, it's not that hard to maintain iterative code in comparison with reactive. So here is the Helidon 4. In Helidon 4, we have obviously switched from the reactive approach to the virtual threads. What we did, we now require Java 21, so that's a minimal version that we can use. But what we did, we have ditched netting. Is there anyone who knows netting? No? The net is very famous framework for working with Java secrets reactively in Java. It's very well fine-tuned, super performant, but it's reactive. And it's, if you remember, tentacles, it grows to your code base and you end up with a reactive API. Otherwise, you don't lose things nothing. So we have got rid of the netting and created a role, etc., which is fine-tuned to work with the virtual threads. We have created full cooperation with the Java team. They helped us to fine-tune it for the best performance we could achieve yet. And it's the heart of the new Helidon 4 release. This is how it looks. You can see there was netting. It's not there anymore. There is a new virtual-based web server now. As you can see from this, while it had impact on the APIs of Helidon SE, which have had the reactive APIs and it's changed to imperative ones. The Helidon dependency this hasn't changed at all because it's been reactive before. It's just less expensive to use it now. There's less abstraction running directly in the virtual threads. And you can see here that we have been working on that in advance, even ways to because Helidon between APIs the reactive ones have been prepared for this switch from the reactive APIs to the competitive ones. So all this time we have been working on the virtual thread-based web server, and we have released Helidon 4 shortly after Java 41 release. Yeah, and this is the difference. In Helidon SE, you can see that in Helidon 3, there was like operators here. You can see all the callbacks. This is just doing some other HTTP call, returning some JSON object and applications. And you can see that it's all happening in the callbacks. You can block anywhere, otherwise some terrible things that happens. In the best case, you will get slower. In worst case, you will block all your workers and your server. The stoppers coming completely. There's just no thing happening in reactive runtimes, and that won't happen here because in Helidon 4 we have the three imperative mode. There is a lot of things you are going from up to down. When you need to wait for this another record call to finish, you just walk here and wait for the response. You cannot wait for anything. You have to wait for this callback that will be executed on someone else's thread. This is all running on a single thread and a single virtual thread. Not going to my platform. If you will be debugging this, you have to jumping line by line, on the streets. When you get a stack trace, something breaks here, you will see exactly the line in which the problem is, the method in which the problem is, unlike here, that will be very, very complicated. And again, Helidon MP is built on top of Helidon SE, so Helidon MP didn't change very much. While Helidon SE has different APIs, it's behind the scenes, and it's not reactive anymore. Here you can see the difference in Helidon MP, how it changed between the reactive Helidon 3 and implemented Helidon 4. It didn't change at all, it didn't stay because it's always imperative. This was just way too expensive because we had to actually offload to the physical thread. So we didn't go and stay imperative. And how we are doing with the performance? If you know the tech and benchmark performance test, this is the last official round, round 22. When we are basically on par with the most with the fastest framework based on Matic, but who's like not all running in Matic. I'm not sure what the Drupal is running. It's Tomcat or something, right? It's budgeted. So it works well. And with each release of Java, while and Ron are optimizing things on sockets, we are actually getting faster for free. So we are waiting for another Java release. And again, this is very important, we got rid of Matic. I will repeat that because it's really important. Matic is a huge and super complicated framework, and it's just not there anymore. It's way simpler now. The code base is cleaner. And as a bonus, we got rid of all those lattice CVEs. Now we have to make our own, but at least you have something from scratch, right? And why we are the difference, again, in Helidon you can turn off the virtual thread support. If you take a look at the virtual thread support in our competitors did, there's usually some on-off switch, right? That's because they are just offloading to the virtual thread from the reactive code. But in Helidon, you cannot do that. It's just not possible. Only way how to run something in the physical thread is actually offload to the physical thread. Because we are running on the virtual thread from the socket up. There is no turn-off switch. You cannot switch to the physical thread. Because if you would do that, our well-optimized conf for the virtual threads would be performing really bad because it optimized which is not for the physical threads. And I mean, if we try that, it goes really bad. Then, we are making synchronous programming, everything is nice and naive and easy to use. it's easy to write and debug. Again, we have a new version. It's not that often you can just switch the thread point to the thread request. It's really fine-tuned for the chip threads. And I made a picture of, yeah, this is nice. This is how it works, for example, in Spring or Tartus when we use this annotation on the chip. They have the method, it's all the tentacles there, right? And then they are also the chip happen running on. Then you are where you want to be, right? That's nice, but there is still a lot of fraction happening. While we have a little bit of the big part of the code, and we are running directly on the sockets in a walking way with the chiplet. So it just cannot be faster. It can be really well optimized. There is a lot of fraction happening if you are keeping the reactive code. And that's all. I have told you everything about the Helidon, and in a while we will try out the XDEF API with new MySQL cluster, which will be released December. What? This summer. Yeah, that's better. So we will try the new pattern, which is virtual thread friendly. So we will try it out on the virtual threads in Helidon for ST. You can find us everywhere again. Helidon is on every social platform imaginable. We are also doing YouTubes. We are kind of YouTubers and writing some articles, and you can find all our sources with help. Any questions?